We often use degrees to measure angles or rotations, where a full circle corresponds to 360 degrees. Well, why 360? Why not 100 or maybe 1,000? I don't know if anyone has the definitive explanation for that. It's possible that 360 was chosen because it was close to the number of days in a year, so that each day the Earth rotated 1 degree around the Sun. Some ancient civilizations used number systems based on 60, so perhaps that gives a connection. Whatever the history is, 360 does happen to work nicely for dividing a full circle into smaller pieces. For instance, a half circle is 180 degrees, a quarter circle, a nice right angle, is 90 degrees. If you break a quarter circle in two, each part is 45 degrees. Breaking it into 3 pieces gives a nice even 30 degrees each. A second system, however, for measuring angles is called radians. The idea is that if you take a circle of radius 1, called the unit circle, an angle measured in radians has the same value as the arc length distance along the circle. Since the circumference of the unit circle is 2 pi, a complete rotation is 2 pi radians. A half circle then would be pi radians, and a quarter circle is pi over 2. If you look at larger or smaller circles, the radius and arc lengths scale proportionally, so radians can still be viewed as the ratio of arc length to radius. You can think of 1 radian as the angle corresponding to an arc length that matches the radius, whatever the radius may be. Because radians are associated with ratios, they're considered unitless. You can write RAD if you wish, but generally when we work with radian angles, we don't indicate any units. I wouldn't say that radians are especially convenient numbers to use for angle measurement, as pi is an irrational number, meaning that its decimal representation goes on forever, has no repeating patterns. And that means that nice divisions of the circle, like halves or quarters, don't correspond to nice decimal numbers when measuring in radians. That's why you'll often see angle measurements like pi over 4 or 5 pi over 6. If you do happen to have a nice decimal number of radians, like 2 radians, it won't correspond to a convenient division of a circle. But the important part is that radians are connected to the arc length distance around a circle. If you had race cars driving around a huge circular track with a 1-mile radius, you could say that a car has driven a distance of 2 miles or an angle of 2 radians. It would be the same location. You'll see in a later video why the connection with arc length distance is important. And if you continue your math studies through calculus, you'll learn important relationships that are true only when using radians.